Welcome to Ask and Learn.
So we have a capacitor with plate separation 1.5 centimeters and area 25 square centimeters. And so this is going to be 0.015 meters. And this is going to be over 100 squared. So this is 2.5 times 10 to the minus 3 square meters. We also know the voltage is 250 volts, and it's filled with air, so the dielectric constant is just 1 to start. Now the charge on the plates, I'm going to make two parts. We have a before and after. The charge on the plates is the capacitance times the voltage, which before is epsilon naught times A divided by D times the voltage. So this is 8.85 times 10 to the minus 12. The area is 2.5 times 10 to the minus 3. And we're dividing by 0.015. And the voltage is 250 volts. So this means the charge is 3.69 times 10 to the minus 10 coulombs. And it's going to be the same after, because conservation of charge. So now, let's see, we want the capacitance after we put the capacitor in water, or in distilled water. So the capacitance is going to be kappa, which is for water, times epsilon naught times A over D, which is kappa for water is 80 times 8.85 times 10 to the minus 12 times 2.5 times 10 to the minus 3 and divide by the distance. So the capacitance after it's immersed in water is 1.18 times 10 to the minus 10 farads. Now the potential difference is pretty simple. We just take the charge and divide by the capacitance. And we already know both of these. So the charge is 3.69 times 10 to the minus 10. And the capacitance is 1.18 times 10 to the minus 10. So we get 3.13 volts. Now to figure out the change in energy, well, the energy before, let's see, we have 1/2 CV squared, but it'll be easier if we substitute the capacitance for Q over V. So we get 1/2 QV, and it's the same over here, but the voltages are different, so this is V1, V2. So the change in energy is going to be the final energy with voltage 2 minus the energy from voltage 1. So this is 1/2 Q times V2 minus V1, we have 3.69 times 10 to the minus 10. And we end with 3.13 volts, and we start with 250 volts. So we're going to get a negative number. And we get minus 4.55 times 10 to the minus 8. And this is in energy change, so it's going to be in joules.